Welcome back. Do you know there is a new Java release that is coming out every 6 months? This has been a recent development, and because of this, you'd see that there are 2 Java releases every year. In this section, let's focus on understanding the different Java versions, how versioning is done, and also let's learn some of the important features in these Java versions. Let's get started. The initial version of Java was called JDK 1.0, and this was released way back, right? This is almost 2.5 decades back, January 1996. There were subsequent releases of JDK 2, 3, and 4, and after that, the major release was J2SE 5.0. This was done in September 2004. As you can see in here, there are 5 releases in almost 8 years. So from 1996 to 2004, there were 5 releases only. The next major release, as far as I'm concerned, is Java SE 8. This was released in March 2014. And as far as I'm concerned, this is the most important Java release because this is the release which brought in functional programming. In an earlier section, we looked at functional programming. Before Java 8, there was no functional programming in Java. Java 8 brought in functional programming constructs like lambda, streams, method references, and all that wonderful stuff. Java SE 9 was released in September 2017. And again, you can see that there are 4 releases in 13 years. From 2004 to 2017, we moved from 5 to 9. So there are about 4 releases in almost 13 years. And starting Java SE 10, which was released in March 2018, Java switched to time-based release versioning. Instead of trying to decide these are the features which would go in and release the version after the features are ready, Java has decided that we would do a release every 6 months. And whatever features are ready, that would be part of that specific release. So starting Java SE 10 is when you would see a number of Java releases coming in. So Java SE 11 came in September 2018. Java SE 12, March 2019, and so on and so forth. One of the latest releases right now is Java SE 16, which was released in March 2021. You can see that from March 2018 to March 2021, we have already went through 6 different releases. One of the important things to remember is that as we switch to bi-yearly releases, the innovation in each of the releases will be very less. If you looked earlier, there are huge differences between each of the Java releases. However, if you look at Java SE 10 versus 11 versus 12 versus 13, the number of new features that are being introduced are far less because these releases are coming in every 6 months. One another thing Java is doing is to release long-term support versions every 3 years. So Java SE 11 is the last long-term support release. The next long-term support release would be Java SE 17. Oracle generally recommends you to use the long-term support releases for production because they'll have support for a very long time. The idea behind this step is to give you a 10,000 feet overview over Java versioning. As you can see, there are a number of new Java versions that are being released of late. I just wanted to give you a little bit of background into what's happening with Java versioning. I'll see you in the next step where we would be talking about some of the important new features that were introduced in different Java versions. I'll see you in the next step. Welcome back. In this step, let's look at some of the important Java new features which were introduced across different Java releases. The idea is to give you an overview of some of the older releases and the newer releases of Java as well. One of the first releases of Java that was very important is J2SE 5.0. This is where enhanced for loop, generics, enums, and autoboxing were introduced into Java language. We looked at all these in earlier sections, and all these features were introduced in Java 5 or J2SE 5.0. The next important release for Java is Java 8. As far as I'm concerned, this is one of the most important Java releases because this is where functional programming was introduced. Before Java 8, there was no functional programming in Java. You cannot do lambdas or streams. I was waiting for functional programming construct in Java for a long time. And finally, in March 2014, with Java 8, we got all the functional programming features. Lambda, streams, static references, and all that wonderful stuff. I love functional programming, and I really loved the Java 8 release. Java 8 release also brought in static methods in interface. In addition to having method definitions for those methods that you want to expose from an interface, you can also have static method definitions in an interface. Java SE9 was one another important Java release where modularization of Java was introduced. The entire JDK is now modularized into multiple modules. Not only that, you can also build your applications in a modularized way. We will look at modularization in depth in a later video. The next important feature which was introduced in Java SE10 is local variable type inference. Whenever we write any program, there are a lot of local variables which we create inside our methods. Some of the times, the variable declaration, the type declaration for a specific variable can get really complex. With Java 10, Java can simplify that for you. Java can automatically infer the type of a local variable. We would look at the details behind local variable type inference a little later. The next important feature is switch expressions. We looked at switch statements in an earlier section. In addition to using switch as a statement, starting Java 14, you can also use switch as an expression. What do you think would be the advantages of doing that? We'll discuss that in a later video. The next important feature is text blocks. If I would want to write a complex piece of text having multiple lines, having double quotes, single quotes, and special characters in Java is very, very difficult. Text blocks makes it very simple. This is introduced in Java 15. The next important feature is record classes. We have created a number of Java beans during the last few sections. For example, the customer bean over here. In the customer bean, we would want to create 3 member variables. We would want to create a constructor. We would want to have getter methods, setter methods, toString, and we might want to implement hash code and equals method as well. You want to do this in most of the beans. In Java 16, a new feature called record classes is introduced, which makes it very, very easy to create classes like this. You can create the entire class like this with 3 lines of code. We would look at record classes a little later as well. In addition to these improvements, in almost every Java versions, there are new methods which are introduced, new APIs which are introduced. And almost every version of Java has performance improvements, especially focusing on garbage collection. We create a number of objects in our program, and when the references for those objects are no longer valid, Java would automatically garbage collect them. Java uses a number of algorithms to do these garbage collection activities. Across Java releases, there are a number of improvements to how garbage collection is done. So you'd see that most of the Java releases have some or other changes with respect to garbage collection and performance. The idea behind this step was to give you a high-level overview of the important new features which were released in a few older releases and the newer releases of Java. I'm sure you're having an interesting time, and I'll see you in the next step. Welcome back. Starting this step, let's look at some of the new APIs which are introduced into Java during the latest releases of Java. Before we get started, let's create a new project. So I'll say new Java project, and I would want to create this with the name Java New API Features. Make sure that you choose the latest execution environment and click Next. Let's not worry about Java modules, so I'll uncheck create module info.java file and I'll say finish. Once the project is created, let's go ahead and create a new file. I'll call this, I would want to create a new class, and I would want to call this, you'd want to play with a few copyOf methods. So I'll call this copyOf API runner. And in the package, I would enter com.in28minutes.api.a. This is the first API that we are exploring. That's why I put A in here. And let's add in a main method also. And let's say finish. So we have the setup ready to start playing with copyOf. What is copyOf? If you look at list or set or map interfaces, there is a new copyOf method which is introduced. So if I actually do a list.copyOf and let's import in list and go to the list class, and if you do a Control O in here and search for copyOf, you'd see a method called copyOf, and you can see that this copyOf method is present since 10. So since Java 10 we have this specific method, and this returns an unmodifiable list containing elements of the given collection. It is important that whenever you pass a collection to this specific method, the collection must be null and it should not contain any null elements. Similar methods also exist in set interface as well. So if you go to the set interface, Java util set in Java13, that's what I'm looking for. And you'd look for copyOf. So there is a copyOf method in the set interface, and you'd also see a corresponding method in the map interface. So I'm choosing Java16 java.util map, and you would see that even here there is a copyOf. So if you select any Java version which is 10 or higher, you should see copyOf methods in list, set, and map. What is use of these methods? Let's say I have an array list. So let's say I have a list of string. Let's say its names is equal to new array list of strings. So this is how we typically define a list of strings. And let's do organize imports to import array list. I'll say names dot add Ranga, and let's say I have a few list of elements in here. Ravi, let's say John. Now if there is a method and I pass in names to that specific method, let's say I would want to create a method, do not change, and I would pass in names to it. And if you go ahead and create the method, create do not change names, what would happen if names actually makes a change to it? Let's say this is a method you don't have control over, it's some other method. And what would happen if somebody goes in and says names.add and should not be allowed? And you go in and say sys out and say names. What would happen? What do you think will happen? Will the value be added or not? You can see that it's added. If you don't want others to make changes, what you can do is you can create a unmodifiable list. How do we create an unmodifiable list usually? One of the options is if you have a static list, if you know the exact values, if I would want to actually create a list with a specific values, hard-coded values, then you can go with the list.of. List.of is introduced in Java 9, and it would actually create you, and it would actually give you a unmodifiable list containing a specific set of elements. However, in our example, this list can be anything. This list of values might be added from anywhere. You might be actually getting the list of values from the database. And before you send to this particular method, you'd want to ensure that nobody will be able to change this list. And that's where you can say list dot copyOf names. Instead of sending names directly, I can send copyOf names. So I can say list of string names. I'll copy this and say copyOf names, and I can send the copyOf names to the other method. And what would happen now? If I try to run this Java application, you'd see that there is an error. It says unsupported operation error. It says immutable collection, and you are trying to add, and that's not allowed. So whenever you'd want to create an immutable list of values from an existing list, you can use the list.copyOf method. Similar methods also exist in set. So if you want to create an immutable set from an existing set, you can use copyOf. And if you want to create an immutable map from an existing map, you can use copyOf again. The great thing about these copyOf methods is if you pass in a immutable map, if the map you are passing in is already immutable, it's unmodifiable, then copyOf will not create a copy, it will return the exact map back because it knows that it's unmodifiable already. In this step, we looked at copyOf methods which were introduced in Java 10. I'll see you in the next step. Welcome back. In this step, let's look at a few file-related methods which were introduced in JDK 11. These are write string and read string. Let's see what's the use of them in this specific step. I'd create a new class and I would create it in the package api.b and I'll call this file read write runner. And let's create a main method and say finish. Now let's create a simple file so that we'll be able to read it. So I'll create it in resources, right click, new folder, and I'll create resources and I'll create a new text file. So I'll say new untitled text file and let's sample line 2, line 3. It's just a sample file that we are creating, and I would store it to Java new API features, resources, and I'll give the name as sample.text. Now I would want to read the sample.text from here. The first thing that we need to do is to create a path variable. So I'll say path is equal to paths.get. Where is the file present? In resources. So the way we can specify that is ./resources/sample.text. Let's do an organize imports. So we have the path ready. With the new method in files, it's very, very easy. All that you need to do is files.read string and pass the path in. And if I do a control1 and import files, I'll be able to do a control1 and add throws declaration so that we actually throw the IO exception. There is a chance that there is an exception that happens when reading the file. And therefore we are defining main method to throw the IO exception. And now again I press control1 and I'll assign it to a new variable. And this is file content. So you can see that we can easily read file content. I can do a sysout and say file content. And if I run it as a Java application, you'd see that I'm now able to print the content of the file. If you want, you can even write it to another file easily. So let's say I have the file content right now. What I would do is I'll say string new file content is equal to file content dot replace, and I would want to replace, let's pick up some text from here, line, and I would want to replace it with, let's say, lines. And we have the new file content, and I would want to write it to a different path. I can say path new file path is equal to paths.get resources/sample new.text. And now I would want to write a file. So I can say files dot write string, and I can say new file path. If you look at the write string method, you'd see that the first is path and the second one is a sequence of characters. So I can send this string out. So I can say new file content. And let's do a launch of this Java application. And you'd see that when I launch it up and go over to the resources and right click, refresh it, you should see a sample new.file in here. And you'd see that it contains lines instead of line. So you can see that with this specific new methods, read string and write string, reading and writing from files becomes even more easier. So if you want to read a string from a file and to write a string to a file. It becomes very, very easy with these read and write string methods. So if you look at the read string documentation, you'd see that it's introduced in Java11. And you can see that by default, it would make use of UTF-8 as the encoding. In this step, we looked at a couple of utility methods which were introduced in JDK11. Welcome back. In this step, let's look at one more important method which was introduced in JDK11, which is predicate not. What is that? When do you use it? Let's look at that right now. So I'll go ahead and create a new package as usual, or actually new class. So let's go ahead and create a new class, and I'll put it in api.c, and I would name it as predicate not runner. What is use of predicate? Earlier, we were doing functional programming, and at that particular point in time, we were using predicates. Let's have a main method in here, and over here, I would want to create a simple list. So list of, let's just say integers, list of integer numbers is equal to list of, let's just create a few numbers at random. So we have a list. Let's organize imports, Java util list, and let's say I would want to define a predicate to filter even numbers. How do I define a predicate? I can say predicate of integer even number filter, or even number predicate is equal to number. We want to check if number mod 2 is equal to 0. If number mod 2 is equal to 0, then it's even number. So let's do organize imports, Java util function predicate. Let's do that. So we have even number predicate defined. Now I can use this predicate and filter only the even numbers. So I can say numbers dot stream dot filter. We can filter using this predicate, and in the remaining ones, I would want to actually do a system.out.println. System.out::println. We are making use of the method reference, and we are printing it off. Let's run this. Alt Shift X, run Java application. Oops, looks like there is a error. Yeah, this one should be stream method. And let's run this right now. Run Java application. Cool. Now you can see that it's printing 4 and 88. So 4 and 88 are the two even numbers in here. Now, let's say I would want to actually use the not of this. So I don't want to print the even numbers. I want to print the odd numbers, numbers which are not even. If I'm using this way of defining the predicate, the way I can actually do that is by actually saying dot even number dot predicate dot negate. So there is a negate method which is present on the predicate itself, which can be used to negate the predicate. And let's see what it would print. Run as Java application. You'd see that it prints the odd numbers. This is one option to do the filtering where negate is very, very easy. However, let's say I'm using a method reference instead of using a predicate. Let's just define a simple method, public static boolean is even, and let's say number is a parameter. So let's just say it's integer number, and this returns this logic. This returns if the number mod 2 is equal to 0. In this kind of situation, how do you use this to do the filtering? So I don't want to do this, but I would want to actually do numbers dot stream dot filter, and over here I can pass in a method reference. So I can say predicate not runner : is even, and then I can say for each. This would also print even numbers. So you can see 4 and 88. However, when you're doing this, you cannot do a dot negate. So there is no negate method which is present in here. And that's the reason why predicate.not method is introduced. So let's try and use that. Predicate.not, and to the not you can pass in the method reference. Actually, it's a small n, not a capital N. Let's format so that you can see the entire lines of code, and let's say save. And let's run this right now. And now you can see that odd numbers are printed. So if you have a method reference and if you want a negation of that, you can use predicate.not. If I go to the documentation of this, control click this, this returns a predicate that is negation of the supplied predicate. And you can see that this is introduced in Java11. In this step, we looked at an interesting method which was introduced in Java11, which is predicate.not. I'm sure you're having an interesting time, and I'll see you in the next step. Welcome back. In the last few steps, we were looking at a number of new API features that were introduced into Java. In this step, let's focus on number of API features which are introduced into the string API. String is one of the APIs which keeps changing across Java releases. There are new methods added in very, very frequently. Let's look at some of the important changes in the last few Java versions. Let's create a new class. So I'll create a new class. I'll call this string new API runner, and I'll call this API.d and say finish. And let's create a main. How did I forget creating the main method? So let's have the main method in here, and let's look at some of the API. One of the typical things that you would do always, let's type in sysout. One of the typical things that you would do always whenever you have a string is to check whether it's a blank. So I can do dot blank. Actually, the method name is blank. If you go to the isBlank method, you'd see that this is introduced in JDK11. This returns if a string is empty or contains only white space characters. So even if you actually have a space in here and run this, you'd see that this returns true. The isBlank method is to check if there are any non-white space characters which are present in this string. Other interesting methods are strip methods which were introduced. So dot strip, and let's put some string in here. This is left, this is right, and we have a space on both sides. And in addition to this, we also have a strip leading and strip trailing. Let's see what would be the output which should be printed by these three methods on Java application. You can see that this one, both sides the spaces are truncated, and here the right side space is left, and over here the left side space is left, right side space is removed. And to easily see that, what I would do is actually, after calling this, I would say replace space with at. You can see where the spaces were. You'd see that when there is a strip call, both leading and trailing are removed. You can see that over here there are no spaces at all. Over here there is space at the right side, but the leading space is removed. And over here there is space on the left side, that's the leading space, but the trailing spaces are removed. So you can see the corresponding methods in here: strip, strip leading, and strip trailing. You'd see that if I have spaces in between, they will remain as is. They will not be removed out. So run as Java application. You can see that the space in between will remain, and it is replaced by the at call in here. If you go over to that specific thing, you would see that this also was introduced in Java 11. And if you look at the documentation, this is a strip method, and it says returns a string whose value is this string with all leading and trailing white space characters removed. Let me copy this again And the next interesting method is to split a string into multiple lines. So in earlier versions of Java, if I would want to split this into multiple lines, line 1 /n, line 2 /n, line 3 /n, line 4. Split becomes much more easier. I can do a run as Java application in here, and you can see that this refers, and you can see that this returns a stream. So what we can do is, instead of doing a system.out.println on this is returning a stream. So I'll say for each system.out.println and run as Java application. You can see that it is split into multiple lines. So if you have a string and you want to break it into a stream, of multiple lines, you can use the lines method. You can go to the lines method and see the documentation related to this. It's introduced in Java11 again. And if you look at the documentation, it says returns a stream of lines extracted from this string, separated by line terminators. One more interesting string method was introduced in Java12. And let's look at it right now. It's, instead of .isBlank, I'd want to do a transform. So I would want to take a specific set of string and I would want to do a transformation on this. So let's say this is upper, and you'd want to use a function to do a transformation. You'd want to use a lambda function to do the transformation. Transform method helps you to do that. So let's say you can define a lambda in here. Take the string, and let's take that string and let's do a substring, and let's truncate the first 2 characters and return a substring after that. So I'm doing a s.substring 2. You can do any other operation as well. This can be a function which does any kind of logic on the string, and you can use that to transform a specific string. And if you do a run as Java application right now, what you would see? PER. So these first 2 characters are cut off. Another interesting method was introduced in Predicate13, which is formatted. So I can take a string and I can say formatted. So let's just say my name is %s, and I can pass in my name, Ranga. I can have a number of other things as well. My age is, and let's a %d, and I can say Ranga, comma, Ranga is very young, 25. Run as Java application. So you can see that you can easily format a string using values. So %s is a string which is replaced by Ranga. My age is %d. %d is a number which is replaced by 25. The order is very, very important. So %s matches against Ranga and %d matches against 25. Until now, we looked at some of the string methods which were introduced in recent Java versions. Now, there is one interesting thing which was added in Java13, which is helpful null pointer exceptions. What is this? Let's just say I want to create a null pointer exception. So I'll say string str is equal to null, and I'll do a str.isBlank. What would happen? Try and guess what would happen? Null pointer exception, right? You can see that this message comes up. Exception in thread main, null pointer exception, cannot invoke string.isBlank because str is null. In earlier versions of Java, it did not contain this much detail. With JDK14, additional context was added into the message. You can see that this is much more clearer. You can see that it's saying, I cannot invoke string.isBlank method because str is null. Now, as soon as you see that the error was thrown on 15, in this particular case, you are sure that str is the one which is null. However, this might not always be the case. Let's say I have a class, like let's say class sample class, and let's say this contains a string. So let's just define a string str is equal to null. And let's say over here, instead of str.isBlank, you are actually using a str from here. So what you have in here is sample class. Sample is equal to new sample class. And over here, you are actually making use of sample dot str dot isBlank. Oops, I'm not able to create an instance because this class should be outside the public class. So this is where it should be. Yep, now I'll be able to create an instance of it. And now let's run this. Now, this is the message which is printed. Let's copy it in. And let's format it a little bit. Now, you can see that it's saying sample.str is null. Earlier, in the before versions of Java, you don't know whether sample is null or sample.str is null. And if you have such a chain of calls which are going on, you don't know which one of them is null. With Java 14, this is made much clearer to us. Sometimes in production, we have errors, and on a specific line, there might be a lot of complex things that are being done, and any of them could be null. And earlier, it was little difficult to solve those problems. And now, because of this clear error message, it would be easier. Along with the null pointer exception, you'd get a hint as to what was null, and that would help you to solve the problem much more easily. In this step, we looked at a few new string APIs and also looked at the enhanced null pointer exception message. I'm sure you're having an interesting time, and I'll see you in the next step. Welcome back. In this step, let's look at another important feature which was introduced in Java 10, which is type inference. Type inference is one major feature which makes the life of a programmer very, very easy. Let's see the advantages that type inferences provide us with. Let's create a Java class, and I would call this type inferences runner. And I'll create it in the package com.in28minutes.api.e and say finish. Let's add a main method and let's go full screen. Some of the times you might have complex definitions for your variables. Let's take a simple example. Let's say I have a list of string, and let's say names is equal to list.of. Let's have a few names. And you might have another list of strings as well. So let's create another list of strings. Let's call this names1 and let's call this names2. And let's have John and Adam in here. Let's organize imports. Java util list. You have two lists, and from this list, I would want to create another list. So list of string names is equal to list.of names1, names2. Now, if I would want to make it even more complex, I can create another list with list of string. The thing you can see in here is the left-hand side declaration is becoming complex. To make it simple, in Java 10, type inference is introduced. Instead of actually trying to define everything which is present in here, you can say var. So instead of defining the type of the variable, you can say Java, I'm lazy. I don't want to figure out what is the type. You figure out what is the type and make sure that the right methods are available. The interesting thing is all the methods that you can do on names are still available. So if you want to do a names.stream and you want to print all the items which are present in there, for each system.out::println. So I'm printing all the lists which are present in here. You'd see that this would work. Run Java application. It's printing both the lists. And if you make an error in the method name, stream1, there's no method called stream1 which is defined on the specific list. It gives you a compilation error. It says the method stream1 is undefined for type list string. Now it's saying the type in here. You have defined it as var. Where is the type coming in from? Java looks at this list.of names1, names2. What is it returning? That type is taken as the type of the var. So instead of you specifying it, Java identifies that from the return value of this particular statement. This is what is called type inference. Type inference is one of the new features where Java compiler infers the type of the variable at compile time. Important thing, it's at compile time. So directly at the time of compilation, Java would infer the type of the variable. So instead of saying list of string numbers, you can say var numbers. And Java would know that this numbers is of type list of string, because it can look at what is present on the right hand side. This is introduced in Java 10. You can also create final variables. If you don't want anybody to be able to modify this, you can say final, but by default, this is not final. So if you just say var names is not final. However, if you want, you can make it final by adding a final in here. You can also use var in loops. So typically we would be doing something of this kind. For int I is equal to 1, I less than equal to 10, I plus plus, do let's say system.out.println sysout I. Over here, instead of int, you can also say var. Not a lot of characters that are being saved, but it's an option. You can do this as well. Or because you have a list in here, I can loop around the list. So I can say, typically I would say string name in names1, and I would print name. So this is the enhanced for loop. And even here, instead of string, I can say var. So you can use var in loops as well. A few important things to remember about vars are you cannot assign null to it. You cannot go and say var abc is equal to null. This is not allowed. You can see there is a compilation error which is coming in. It says cannot infer type for local variable initialized to null. Only if some kind of an object is present on the right hand side, Java would be able to infer the type. Otherwise, nope, it's not allowed. Another important thing to remember is var is not a keyword. Why is it important? It means that I can have a variable with the name as var. You can even create a method with the name as var as well. So var is not a keyword. The important thing to remember is var can make things simple, but it can also make things complex if you don't use it the right way. So make sure that your variable names are good. So whenever you're using var, make sure that your variable names are really good. They are very, very expressive, because somebody who looks at the type will not be able to see the type in here. He would just see a var. Similar things can be done here as well. So when you do something of this kind, whoever is looking at this code will not know that this is a list of string. So the naming of variables becomes really, really important when you do something of this kind. And it's very, very important to have small scopes for your variables. If you define a var somewhere and use it somewhere, it becomes difficult to understand the program. One of the places where you can use var is if you'd want to improve the readability for chained expressions. Some of the times you have a huge list of method calls which are being done. You might have list of rangaravi.stream .filter s, and I would want to filter those with length less than 20 or less than 5 dot for each system dot out : println. So you can see that you can write code like this. Oops, this should be scn length. You can see that you can write complex code like this. This is a huge chain of commands. In this kind of situations, what you can do is you can break it down by using a var. Let's run this and see what it would print. You'd see that it would only print Ravi because Ravi is the only one which has length less than 5. Instead of having the entire code on one line, what you can do is actually probably extract a variable for one of these. So I can say, I can do Alt-Shift-L. I can say refactor, extract local variable, and I can call this filter. And you can see that it's saying stream of string filter. I can say var. So I can create an intermediate var variable and make the code more readable. In this step, we looked at a new feature in Java 10, local variable type inference. I'll see you in the next step. Welcome back. In this step, let's look at switch expression. In earlier sections, we looked at switch statement. What is switch expression and why do we need it? That's what we'd be looking at in this specific step. Switch expression allows you to create expressions using switch statement. This is released in JDK14. We talked about the fact that new releases of Java are made every 6 months. And with these new releases, sometimes Java also releases features in preview. So the switch expression feature was released as preview in JDK 12 and 13 and was made finalized in JDK 14. In JDK 12 and 13 also you could have tested the switch expression feature by enabling a preview flag. However, from JDK 14 it has been made a standard feature. Let's look at a couple of examples for switch expressions. Let's look at examples for switch expression. Let's go in as usual. Let's create a new class and I'll call this switch expression runner, and let's use the package.f. Let's create a main method and say finish. And let's go ahead and play with it here. Let's create a simple method, public static. Let's just return a string back. Let's say find day of the week, and let's say the value which is passed in is an integer. So you are passed in a value between 0 and 6 and you have to determine the day of the week. Let's say int day. And one of the easiest ways to implement this is to go for a switch, right? Switch on day, and you can actually create a local variable saying string day is equal day of week is equal to empty or null at the start. You can say case 0, let's say it's Sunday. You can say day of week is equal to Sunday, and you can say break. And similar to that, you have other statements also. So case 1, case 2, case 3, Sunday, Monday, Tuesday, Wednesday, and so on and so forth. You can write the cases for the other ones. I can say day of week is equal to error or invalid, or you can even throw an exception from here. I can say throw new illegal argument exception, invalid plus day, invalid option plus day. And at the end, what we can do is we can say return day of week. This is typically the way we make use of this switch statement. You can see that there is a lot of ceremony involved when we are doing a switch statement, because if I don't have a break, what would happen? There is a fall through. The code would fall through to Monday, Tuesday, and so on and so forth. That's the reason why we need a break. With Java 14, you have an option to simplify this further. So I'll copy the same method again. I'll call this file day of the week with switch expression. And over here, what you can do is, instead of actually assigning it to a local variable, I can say case 0, and this is similar to a lambda expression. So hyphen greater than. So this is very, very similar to a lambda expression. However, when you are doing this, you don't really need to use the break. And you can see that case 1 is giving you an error right now. So I'll go ahead and fix that. So I'll do the same change over here. And let's remove the break as well. And over here as well, I can do that. And you can do the same over here as well. And over here, I would change the default as well to do the same thing. And over here, instead of doing this, assigning to empty and that, I would actually directly assign it like this. At the end of the switch statement, I would need to introduce a semicolon so that the code would compile. So you can see that this code is much more simpler. So over here, what we are saying is if case is 0, day of week is Sunday. Case is 1, day of week is Monday. So what we have done is we have converted the switch statement to a switch expression, and this expression returns a value. What is the value which is returned by this expression? It is the day of the week. Sometimes you might have complex things to do. So in here, if you just don't want to do Sunday directly, you might have some logic before you find it out that it's Sunday. In that kind of situations, you can put it within braces. Once you put braces, the syntax changes a little. Let's do that right now. So now we have complex logic in here. So what we'll do in here is, let's say, do a complex logic system.out.println and a lot of other things. Whatever you'd want to do in here, you can do that. Do some complex logic here. And after that, you'd want to return Sunday back. How can you return the Sunday back over here? You cannot do return. The way you can do that is yield. So the statement to return the final calculated value is yield. And over here, when you're using braces, you don't need the semicolon at the end. So now I can save this. I want this switch expression to evaluate to this value if case is 0. In that kind of situation, I can use yield and return this value back. One of the important things to remember in the case of a switch expression is that there is no fall through. In the case of switch, you need a break because the logic falls through. So if this case meets, if case 0 is success, if you don't have a break, what would happen? It would fall through to case 1. If case 1 does not have a break, it would fall through to case 2. However, in the case of switch expression, there is no fall through at all. If you are returning Monday as the value of the expression, it would directly be returned. It would not go to the next case statement. The same is the case with yield as well. As soon as you yield a value, the value will be written back as the value of the expression. In this step, we looked at switch expressions. I'm sure you're having an interesting time, and I'll see you in the next step. Welcome back. Let's look at another new feature in Java, which is text blocks. Look at this line of code. Is it easy to read what it's going to print? You can see that we have the slashes in here to escape double quotes. And we have /n to indicate that it's new line. And this kind of code is difficult to read. And that's the reason why Java introduced text blocks, where it makes it very easy to look at the string and identify what would be printed. So you can see that this is a text block by 3 double quotes over here and 3 double quotes over here. And within these 3 double quotes, whatever is present is printed as is. So this is used to simplify complex text strings. This is released in JDK15. This was a preview feature in JDK13 and 14. Let's quickly look at an example. Let's follow the tradition of creating a new class, and I'll call this text blocks runner. Let's add a main method, and let's use the package api.g and say finish. And over here, let's create a text block. So string str is equal to these 3 and followed by your text that you want to print. So line 1, line 2, line 3. And let's do a sysout of str. Let's see what would be printed. Let's not do a print ln. Let's do just a print. Run as Java application. You can see line 1, line 2, line 3, which are printed. And there's a new line at the end of line 3 as well, because that's how we have it in here. If you don't want a new line at the end of line 3, you can actually remove this. You can actually put the 3 quotes right after line 3, and then you would see right click run as Java application. Over here at the end of line 3, there is no new line character. So if you see this, that's the last character. 3 is the last character, and after that there is no new character. So if you want a new line at the end, you can put it this way. If you don't want a new line, you can put it this way. The other interesting thing is how you start it. You cannot start it this way. So if I have 3 quotes, right after that, I cannot put line 1. This would give you a compilation error. After 3 quotes, the character which should be present is new line. And only after that, you should have your text. So 3 quotes followed by new line character, followed by your text. And that's what is printed out. And over here, you can have formatting, individual formatting for these lines. If you look at this thing, there is formatting in here. And because there is same formatting for all the 3 lines, this formatting is ignored. However, if you have specific formatting for a specific line, you would see that that would be retained. So if I'm entering 3 spaces before line 2, you would see that that formatting would be retained because that's specific to line 2. So you can see that these 3 spaces instead in front of line 2 are printed as is. So if I have another line in here, line 3 and line 4, let's add another one actually, line 4, let's have 1, 2, 3, 4 spaces. So line 5, you'd see that all this formatting would be retained. So if I make this line 6 and print, right click, run as Java application, you can see that the entire formatting that you have in here is retained. And it's very interesting that you can use double quotes as well. So if you have double quotes in a string, you have to escape them. You have to put a slash in front of them, and it makes it very, very complex. But when you're using text blocks, no worries. You can directly add double quotes, and you would see that double quotes would be part of your string. Important thing to remember is that in the first line of your text block, there should be 3 quotes followed by a line terminator or a new line character. You cannot have the entire text block on a single line. You cannot have a text block of this kind. str1 is equal to all 3 quotes here, and let's say I would want to have my string and 3 quotes in here. This is not valid. You need to always start the value on the next line. So this is where you need to start the value, and you can choose to end it on the same line as the text. However, following the first 3 quotes, there should not be any text. There should be a new line character. That's how the compiler identifies that this is a text block. We talked about automatic alignment already. We saw that if there is some space before the entire string, which is common across multiple lines, it's ignored. However, if there is specific formatting for a specific line, which is more than the earlier lines, then that formatting is retained. So there is automatic alignment which is done, and trailing white space is also stripped. So if you have any white space in here, in any of the lines, all that is stripped off. So if I save this and run as Java application, if you take the cursor at the end, you'd see that the white space is not printed. So if you have any trailing white space, it's stripped off. And you can use text blocks wherever you can use a string. And all the operations that you can perform on a string, you can also perform them on text blocks. Now, my recommended approach of using text blocks would be something like this. So the best way to define a text block would be string text block is equal to something like this, and you can have all the text in consecutive lines right beneath it. So line 1, line 2, line 3, line 4 have a ending quote starting the same character as the line 4. So this is easily identifiable as a text block. So this is how I would recommend you to have text blocks formatted. The interesting thing is you can also use things like formatted. So if I have something of this kind, line 1 colon %s colon %s, you can add %s for the other ones. You can do a dot formatted, and you can pass the values which you'd want to format. So let's say I would want to put line 1 and some value and some other value. So formatting of this kind. So if you have an email template in here, so this is a template, and you can replace the values in the template in here, and you can try and print the text block over here. So system.out.print text block. What would it print? Run as Java application. You can see that it's printing this string, this template, with the values replaced. So using text blocks, you can easily create templates for emails or things like that. In this step, we played around with text blocks. I'm sure you're having an interesting time, and I'll see you in the next step. Welcome back. In this step, let's play around with records. What is a record? Let's look at a few classes that we created in Advanced Object-Oriented Programming. You would see that most of these classes have the member variables, the constructor, toString, and a lot of other methods which are defined. Let's pick up another class from inheritance. Let's pick up the employee class. You can see that you have a number of member variables, you have a constructor, you have getters, setters, toString, and a lot of other methods. You might also want to define equals, hash code, and other methods as well. And this is the exact same thing that we would do across multiple beans. How do we eliminate that verbosity? How do we eliminate the need to define constructors, to define getter methods, to define toString methods, equals, hash code methods? That's where this feature called records was introduced into Java. When you're using records, the public accessor methods, constructor, equals, hash code, and toString methods are automatically created for you. You can also add custom implementations for these methods if you want. Let's take a quick look. I'll close all the files which we have opened, and let's go over to the Java new API features project that we created. These are not really API features, but let's make use of the same project for this as well. So let's go ahead and say new class, and I would say API EFGH, and over here we would want to play with records. Records runner. Let's add a main method in and say finish. Now over here, let's create a record. Record person string name. Let's say I would want to have email, and let's say I would want to have a phone number. String phone number, followed by open brace and a closing brace. That's all you'd need to create a record. Once you have a record, you can actually create a new instance of the record. So once we created a record of this kind, then I can say person is equal to new person. And over here, I need to pass in the name, email. So let's say Ranga, and let's say Ranga at in28minutes.com comma 12345678990. So a person is automatically created, and you can even do a sysout of person. Let's see what would happen. So instead of writing all that code to create a constructor, to create a toString and all that, this makes it very, very simple. If you run this right now, you can see person name is equal to Ranga, email is equal to this, phone number is equal to this. A person object is created with these as member variables, name, email, and phone number. And you can also compare. So I can say person is 1, let's say person 2. Person 2 has different values, let's say Ranga 1. In that kind of situation, you can say person dot equals. A automatic equals method is also created. Oops, I would want to say person dot equals and person dot equals person 2. And if I run this right now, you would see that the first one would be true, the second one is false. If all the elements have equal values, then these two objects are considered to be equal. So there is a predefined equals method which is defined. Similar to that, a hash code method is also defined. Similar to that, even accessor methods are defined. So you can say system.out.println person.name. It would get the name of this specific person. I would remove the comment out the equals parts of it. So I'm not really worried about this. So let's move these down. Let's focus on person.name. Let's see what it would print. What would it print? You can see that it prints Ranga. So you can get name or email or phone number. So person.email, person.phone number are the accessor methods which are present in here. These are called public accessor methods. So a constructor is provided, accessor methods are provided, hash code and equal methods are provided, and toString methods are also provided for you by default when you create a record. You can also create custom implementations if you want. If you want to allow creation. Now over here, I can also define an explicit constructor if I would want. So if I'm not happy with the default constructor which is provided, I can go in here and say, I want to create my own constructor. So I can say person this, and I can go ahead and define the constructor. And over here I can say this dot name is equal to name, this dot email is equal to email, and this dot phone number is equal to phone number. And you can add validations if you want. So if this dot name is equal to null, throw illegal argument exception, name is null. So something of this kind is also possible. Let's do an organize imports. Actually, it should be new illegal argument exception. So let's, and this should be name is equal to null. So if the name which is passed in is null, we would want to throw a illegal argument exception, and name is null. So we would want to add validation. We can define a custom constructor like this, and you can use that to create your object. You can also override other methods which are present in here. One of the things that you are observing in here is when we would want to define our own custom constructor, there is again the boilerplate which is coming in. So I have to write all this kind of code. And there is a simpler way of actually doing this. This simpler way is called a compact constructor. How do I create a compact constructor? I can remove the arguments from here completely, and I can remove these 3 lines of code. This is what is called a compact constructor. So you don't really need to say this dot name is equal to name, this dot email is equal to email, this dot phone number is equal to phone number. You just need to say person, and you can define your validations in here. So whatever validations you want to be done, you can do them. And after that, the object would be automatically created for you. Let's look at a few things that you need to remember. Number one is compact constructors are only allowed in records. Number one is that compact constructors are only allowed in records. So only inside records you can use compact constructors. In normal Java classes, you cannot use a compact constructor. You can add static fields, static initializers, and static methods inside your records. However, you'll not be able to add instance variables or instance initializers. So you cannot go into a thing in here and say, I would want to add an int number. This is an instance variable, and that's not allowed. Non-static fields are not allowed. However, you can create static fields. So if you make it static, that is allowed. One of the non-static things that is allowed is to create instance methods. If the name method is not sufficient, if you want to add additional logic, you can say name, and you can go ahead and define your own name method. So return name, and before that you can add your own logic. So you can say sys out and do something in here before you would actually return the name back. And whenever you are giving a definition for an accessor method, this should be public. So public string name, do your logic, and return the value you would want to return. So you can add static fields, static initializers, and static methods, but you cannot add instance variables or instance initializers. However, you can add instance methods. We looked at an example of an instance method that we added in just now. In this step, we looked at records.